eyes are messed up today. I spent 17 hours straight in virtual reality yesterday. I went to church in VR just cause. As one does. Then I've been playing this tabletop D&D thing called Demio, and we had this epic fight against the Rat King. Man, that lasted like 2 hours, just this one fight. It was touch and go there for a while, but we won. so that was 2 hours. Then I watched a 3D Transformers movie. I was doing some 360 stuff. And I think I fell asleep. There's a point where this, now that I'm hearing it out loud, it's I know I've made my setup too good. So I play completely wirelessly on the Oculus Quest 2 over a dual 5.4 gigahertz band to my VR gaming rig down the basement. So I actually play in my zero gravity chair, which is like completely comfortable. Yeah, so I mean, there's like no reason to like be uncomfortable. And I'm building a rotation thing that I can put the zero gravity chair on, that when I turn my head, it'll rotate. So I can do 360 degrees without physically having to do anything. Because I mean, actually my legs are like super wobbly today from not using them yesterday. First world problems. All right, so let's finish up our Towers of Hanoi so we can get into Shunting Yard, right? All right. And this is our code, right? All right, so at the end of class, well, last class, and I'll investigate it a little bit more, but I mean, I think it's relatively unimportant. But last class, we kind of looked at least that idea that arrays in C and C++ can't advertise their size. Old style arrays, we can build, use new style collections like vectors and stuff, which we're not going to do because we're building our own collection types in here, which can advertise their size. We did look at a couple of kind of hacks on how we can maybe get it to advertise its size in here. But we saw that there was a difference between creating an array using the array syntax, this guy, and then allocating memory for an array. Not as much information was stored, or a different kind of information was stored. I'm still confident I can come up with a way with this to be able to reverse engineer and calculate the length of an array's, contents. But I think from a historical computer science perspective, it's fair enough to say, hey, in older languages like this, arrays are pure primitive types, and as such can only hold a value. They hold the memory address, not additional information. Okay. And all that was to explain why we were going to say it was okay to hard code a 3 in here for our particular game. Because officially, I'm telling you, it's very likely never a good idea to have a hard-coded number somewhere in your code. But in this particular case, because we've gone through the thought process of it, we're going to say, you know what, we're just going to leave it alone and move on with life. All right, then we also looked at how do you read stuff in from the user right here. And we saw that the cin function does convert it to its correct type, so we can read in a number. So what we want to do is we want to create a cadence inside of our Towers of Hanoi game that effectively plays the game and just keeps asking the user, what's your source tower, what's your destination tower, source tower, destination tower, and then makes that move in the middle so we can play our game. All right, so let's start off with that piece. So with that in mind, I'm actually going to make the display and the move functions. I'm going to move them into the private section. We don't need to have access to those outside of the Towers of Hanoi, the TOH class, right? Outside of the TOH class, we do want to be able to say, play the game. And then inside the class, we'll reference the display, we'll reference move, those things. All right, so we're going to have a void play game. And we'll go ahead and implement this guy. We don't have to change anything with our move or display. We just changed its permissions by moving it under that different section because of where we need access to it. We didn't need access to it in as many places anymore. All right, so inside play game, for right now, let's just say we're going to allow them to keep changing the board indefinitely. So we'll say while true, do some stuff. All right. And what we're going to do is we're going to enter in a couple of pieces of information. So we're going to say int source, destination. So we'll say cout, enter the source tower. And we probably want to go ahead and display our current board so they can see what the current state of things is. And I think we upgrade it to 4K last time. I'm pretty sure we left it at still 1080p. I don't remember which, but it's good. All right. So then we use cin to read this into a variable. And notice I'm not doing that endl thing. That way, when I say I write something, here's a prompt, it's asking for it's it's going to be right at the end of the line where we type in the number and press enter. Destination. And then we'll say this move and was it source and then destination. That's probably what we said. Confirm that here real quick. Move takes in a source, then a destination. All right. So what are we going to do forever? We'll show the board, ask them for the source, ask them for the destination, move, do a move on that source and destination, spin back up, show the board again, the updated board. Make sense? So we're still not applying our rules to it yet, but now we're making it interactive where the user can sit there and type stuff in and see the board update. So we'll go back to main. We'll gut most of this stuff. We'll say the game, play game. That should be all we have to do there. And then internally, that's going to do the thing we just wrote. Oh, wrong. Like colon instead of semicolon. All right, so here's our current thing. So we're going to say tower 0 to tower 2, tower 0 to tower 1, tower 2 to tower 1, tower 0 to tower 2, tower 1 to tower 0, tower 1 to tower 2, tower 0 to tower 2. So we just played the perfect game of Hanoi. Doesn't know we're done. Actually, hold on. Oh yeah, it's correct. Because this is when we did the 4K upgrade, we put the title below it. All right. So right now the game doesn't know when we're actually done, and it didn't police us because we technically those moves will let us do illegal things. All right. So, and at this point, we also don't have a way of stopping our game. You know, the idea should be once you have won, we'll do some sort of, hey, congratulations, yada, 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 and break out of that while loop. So I'll go ahead and just stop this for now. Yeah, that's pretty handy. So let's go back into our implementation here. For play game, this is all fine for right now, but we do need to go in now to our move function and change the rules by which we try to do a move. Okay? And then make sure that if a move doesn't work out, we put everything back the way it was supposed to be. Make sense? All right, so here's our move function. So right now, our move function literally just says, look, these things are stacks. I'm going to pop off one. I'm going to push onto another. Boom, done. That's that's the end of it. All right. So what we're going to do is we're going to now get our couple of disks that ask some questions about whether or not, and actually we can even ask the question beforehand. We can say something like, if the towers at bucket source peak, it's not equal to null. So this if statement effectively says, is my source tower even a legal source? So if the top of my source tower is something other than null, that means at the very least, I have a disk at the top of that source tower that I could pop off and try to put someplace else. Otherwise, we're definitely not going to do anything in here. It doesn't matter what our destination was, right? So kind of our first filter is going to say, look, does the source have something on it that could go someplace else? I'll go ahead and get rid of that line. So assuming that's a yes, if it's a no, this method will just end. We didn't do anything. And the next time we display, it'll update and show that it's the same board as we had before. All right. So if we're in here, now we want to ask if the disk that we are going to, well, we probably can ask the next question, is the destination, let's see, we would always, let's ask it like this. We can say if the towers at bucket destination peak. So we'll go ahead and look at the top of the destination tower. And if that is equal to null, if there's nothing in my destination tower, then I'm free and clear, right? If I'm in here, that means there's something on my source tower and the place that you've told me to put it doesn't have anything in there. There's no rules to apply. We can just do it. So we'll say the towers at bucket destination push the towers at bucket source pop. Remember, pop actually removes it from the top of the stack. Peek does not remove it, just lets us look at it, lets us peek at it. Okay. So if we're in this if statement, that means that we are free and clear. Destination is empty right now. So we can just go ahead and push the value that we're going to pop off of the source stack onto there. Else, we have some rules to apply. That means if we're in this else, that means we definitely have something on our source stack. We definitely have something on our destination stack. And now we want to ask the question, is that going to be a legal move? Okay, and it's only a legal move if the thing that's on our source stack has a size. Do we call it size? Has a size. We're going to have to write the ability to get size, right? Has a size that is smaller than the thing that's at the top of our destination stack, that guy's size. So we're going to have to go over to disk. Because size is a private variable, we're going to go ahead and give ourselves a public function called getSize. Now, quick question. What is the advantage of having a private variable named size here and then a public function called getSize? What's the advantage of that as opposed to just making size public? Go ahead. Yeah, anybody could change it. If I make size public, if I move this guy here, we've effectively given read and write privileges to that field. That makes sense? Whereas if I keep it private here, right now it's you have no public privileges to it. You only have access to that inside of the disk class. And then I've gone ahead and optionally said, you know what? I will let you read from that private variable, but not write to it. This gives us more granular control. We're giving read-only access to that private number instead of read-write access. Does that make sense? It's an important distinction because as a inexperienced programmer, we might say that, oh, well, it's so much more convenient just to make that guy public because it made the error go away. And now life is great, everything's good, but we did it for the wrong reason. Make sense? So that goes back to when we first talked about objects in the second half of CSC300, we would have said something like, always make everything private to begin with, and then loosen the reins as you need to. And we're seeing it here that I made this guy completely private and didn't even give ourselves read access until right now when I'm bumping into a situation where I do need read access. All right. So I'm an advocate of letting your code kind of grow organically like that, as opposed to trying to solve all the world's problems. When you first write the, in this case, when we wrote the disk class, we could have said, here's the 50 functions we think we might have to do with the disk class, and then of which you use 3 of them. Write what you need, go back and add to it as you need more. That's kind of the advantage of writing stuff in software. Go ahead. Say this again. Well, you could, but then you have to ask the question on it, because of the way we wrote it, the answer is yes. We could just make it public. So I'll flip it back on you. What is the advantage of giving ourselves access to this private field through these 2 public fields, specifically the set field? What's the advantage of us doing it through a function as opposed to directly through the field? You have an opportunity to interact. You have the opportunity to ask some questions. You're not just going to willy-nilly let them just change it. unbeknownst to you. So kind of related to like, at least you know what's happening, right? But in this case, we could say, look, you want to set the next disk here? Fine, but let's talk about this. Let's ask a couple of questions inside. Yeah, I'm going to go back over to the implementation of this. I'll bring this with me. In this case, we are not asking questions. So in this particular case, what you said would be reasonable. If the way we're using that field is just read and write all day long with no oversight, make it public, move on with life. I would still say that maybe this looks a little cleaner, but it's a weak argument. If you're not going to give yourself any oversight, if we're not saying, look, I'm only going to let you do this if this guy here meets some criteria or something like that. So potentially you could have built in your Towers of Hanoi rules into the disk itself, right? I would say that maybe that would have been a little bit difficult to keep track of, because now you're spreading your rule set kind of throughout the, almost the DNA of your towers. Certainly possible, okay, but now you're just saying, look, I'm just going to toss this thing in there and it's going to do what it's going to do, and I'm going to be ready to catch something if it spits it back out, as opposed to only put it in if I had a confidence that it was going to work out, right? But in this case, since we're not asking any questions about this, what you said is correct, but writing it like this inside of a function does at least give us the option to say, only do this under some criteria. All right, so we're going to go ahead and give ourselves the ability to read the size variable. All right, so that's all we actually did in here. So we just added a read-only ability, read-only function to that private field. So now we can go back to our game. So if we're inside of this else, we can add some comments. Our destination tower is empty, so just make the move. Our destination tower has something in it, so we need to make sure the move is legal. The source tower has something in it, so we can at least try to make the move below. Just adding a little commentary into there to add some meaning into what those various if statements are saying. I would say that maybe comments like this are starting to get borderline required, because we're right in the middle of the application right now, so everything's kind of fresh in our mind. But if you came back to this 6 months from now, maybe this stuff isn't necessarily as quick and easy to just read. You might appreciate a little bit of human speak here, kind of explaining, hey, this if statement's effectively saying that. Only try to do anything if you had something to start with the move. Okay. So if we're in this else, now we need to ask a question. We want to say, only allow the move if the thing at the top of the destination tower is larger than the thing at the top of the source tower. Or if you want to flip that around, the thing at the top of the source tower has a size that's smaller than the thing at the top of the destination tower. If, and you could have linked this to the else if you wanted to, but since we're kind of structurally doing this, I think having these nested ifs is reasonably okay because it allows us to be fairly granular and maybe be less error prone at the cost of a couple extra curly braces. So if the towers at bucket source, which if we're here, we know that guy has something in it. Peak. Get size. If that guy's size is less than this, the towers at bucket destination, peak, get size. And we know there's something in that tower. So peaking is going to be fine. We know we'll get something. So if the source tower's top has a size that's less than the destination tower's top, then we know this is a legal move. And we can do the exact same thing as we did up there. So with that in mind, you could have taken this Boolean expression and tossed it as an or up here. So you could have said that or that whole thing. And you can kick it down a line. That's allowed. Something like that. Probably want to have the comments be a little bit, well, would you agree that this starts getting a little bit unwieldy? It's accurate. It solves the problem, but I'm not sure we really benefit that much. So I would make the argument, like, let's keep it separate. If the destination's empty, make the move. Else, if the destination, so you could put this in an else if here. We would probably call that and say it's reasonable. But else, put my little commentary, if the destination has a top that is larger than what I'm trying to take off the source, then this is a legal move and we'll go ahead and do it. If I wanted to put a little commentary, I could do it else. See out. Illegal move. Like that. And I could do an else on this one. Nothing in the source tower. Not necessary, but if you wanted to give a little feedback onto what they did wrong, you could. All right. So now our move function only does something if you gave it a legitimate move to make. Go and run this again. Didn't I use the completion to spell it right? Or did I misspell it someplace else? And I completed it with my misspelling. Destination. That's a word. I only had one misspelling. So I probably didn't use it. All right, so let's go ahead and let's first test one of our illegal things. So we're going to have a source tower of 1. Destination tower doesn't matter. It should scream at us. Nothing in the source tower. Actually, will this let me, I'll test it here in a second. Actually, let me test it now. For no good reason other than just completeness here. So we've been using C out and C in. I think there is a C error. Look at IO stream. I can't get a clean answer there. Let me just try it. I think it's C. Is this my code? Oh, program is running. I think it's C error like that. We'll know pretty quick. Yep. So we'll do 1, 2, and let's see if it makes it in red. No. Well, that was a waste of time. So there are 2 output streams and 1 input stream in your most operating systems. You have a standard output stream, and then you have a standard error output stream. So 2 different output streams, and then you usually have 1 input stream, which comes from the keyboard. How many of you have had the 350 class, the operating systems class? Right, nobody. Okay, so we'll go ahead and throw the trivia question out and see if do you know why there might be 2 different output streams? It involves error logging. So we typically recognize that on our operating systems, it might keep like log files where when things went wrong, it remembers it somewhere, right? So having 2 different output streams where we make error messages go out to the error stream and we make normal output go out to the output stream, even though the default destination of both of those is the monitor, you can choose to redirect errors, specifically only errors, to a different place. Maybe it goes to the screen and to a file, or maybe it just goes to that file. But you can choose to, now that you have them on 2 different channels, you can say, I want this one channel to go someplace else, or at least be duplicated someplace else. And I'm not interested in what's going over this channel. Make some sense? All right, so that's the reason why both of those exist. What you will see sometimes is, depending on the terminal we're running in, when you use C error, it'll show it up in red, like kind of a visibly noticeable error message, something like that. Their thing didn't do that. That's fine. We'll leave it in there just as we're saying there was an error, so we'll write it out over C error. All right, so we'll go ahead and test this, make sure we can actually do some moves. All right, so source tower, we'll go ahead and choose 0. Destination tower, we'll choose 2. Source tower, we'll choose 0. And we're going to try to do it onto destination tower 2, which should be illegal. There's our illegal move. So let's choose source tower 0, destination 1, source tower 2, destination 1, 0, 2, 1, 0, 1, 2, 0, 2. Something like that. All right, so we're able to play our game. All right. When do we know that we have a winner? What are some ways we can detect that the game has been won? Okay. Does that mean that if I had everything on tower 1 instead of tower 2, that would be a winning? We only win if everything's collected on tower 2, not if everything's collected on something other than tower 0. But let's assume we'll amend your answer a little bit and say if everything's not on tower 0 or tower 1, so it's on tower 2. How do we ask? Are all the disks on tower 2? Could do that. We could do that. We could say, look, let's peek at tower 0. If I don't find anything there, and I peeked at tower 1, I didn't find anything there, they must all be on the, on the last guy. Okay. Absolutely, we could do that. So let's go ahead and write it that way. And then we'll talk about an alternative. But I like that solution. It's a reasonable enough solution. And what's I'll ask you what's better about that solution. That's the best solution, in my view. I'll ask you why it's the best solution compared to the other one here in a minute. But let's go to our, where's my play game? So we no longer want to do this forever, right? We want to do this as long as there is something on tower 0 and on tower 1. Right? As soon as those 2 towers empty out, everything must be on the last tower. So while this, I got to stop it running first. This, the towers at bucket 0 peak is not equal to null. And let's see. And this, and I might come back to this in a second. Towers at bucket 1 peak it's not equal to null. This needs to be an OR. So if this tower has something on it, or this tower has something on it, keep going. If either of those things are true. Make sense? So now with this, actually we'll go ahead and do a little see out winner. All right, go ahead and play our game. 0, 2, 0, 1. 2, 1, 0, 2. 1, 0, 1, 2, 0, 2. Probably should show it one more time just so we see the full tower, but now we're detecting a winner. All right. So what would be, so we'll call that good. I'll go ahead and put my one last display in there, but we don't need to run it again. So what would be an alternative to this? And then why is that alternative not as good? Presumably, it's not horrible, but why is it possibly not as good? What?
Just loop through tower 2 and then just check that all the 3 disks that you initialized initially.
We can. So let me check something. Couldn't we just ask tower 2's count? Yeah, I mean, what he said is reasonable. Just said, look, I know you've been keeping track of count. I'm going to ignore that. And I'm just going to count it myself. You could certainly do that. But it actually is a good example in this case, because this is something that I think starts happening, especially when you're just starting to learn these data structures things. And it's not so much about the data structures themselves. It's about this inner working stuff. We get so used to this next node and previous node and hooking up pointers and stuff like that, that you forget that what you're actually doing is inventing a tool. And that tool has convenience functions that allows you to do stuff. So kind of the obvious example, I see this on the exam. So I'm kind of giving you a fair warning before like the midterm, when we get to it. I'll ask you some question on the midterm. It is entirely asking you to just use things like add front or add end in the linked list. But your answer will be like 20 lines of code where you're traversing this list. You're basically saying, look, I'm going to rip the cover off this thing. I'm going to dive in. I'm going to start climbing down through this list just to get the thing at the end. When you could have just said get end. Called one function that you already wrote all that manipulation stuff. And then you stuffed it inside this object so you didn't have to deal with the details. So don't forget that we are inventing tools that we can then conveniently use. We only had to deal with those details one time. Now, this is like the small example of that, right? Because I mean, we hadn't referred back to this. When I clicked on Towers HPP, I was really checking, did we keep track of a count when we wrote this? But since this dude knows how to give us its count, we do have to build, give us a getter for that, right? So we could ask if this tower's count is 3. So if I wrote int get count in here. Tower CPP. Return the count variable. Now we can ask if the count is something. So in my game, instead of saying this, I could say while the towers at bucket 2 get count is less than 3. Keep doing all this stuff as long as the last tower has fewer than 3 disks on it. Now, the interesting question, though, the follow-up is, most of us would say this looks cleaner than all of this. But is it better? What does this second version, which I've already said I think is better, what does that let us accomplish that this guy doesn't, or doesn't without modification? And this might not necessarily be obvious to you unless you play in the International Professional Towers of Hanoi League. More discs and more towers. Potentially, we're limiting ourselves on towers here without a hard-coded 3. But you could have your first tower have a lot of discs on it, right? You don't have to have 3 discs. You could have 7 discs. Okay, so this guy says, look, I don't care how many discs you start off with. When the first 2 towers are empty, you won. Make sense? Where this guy just says, look, well, I'm going to assume that if you had 7 discs when you start off with, and you're going to say, look, just get 3 of them over there. Once you get 3 of them over in that far right, there was a guy from Germany that tried that in last year's national championship. Referees threw him right out. I think this guy really thinks he plays Towers of Hanoi professional. I might. Only in VR though. That's what happened around hour 14, 15, 16. As I got into this Towers of Hanoi death match type in VR, and things kind of went south real quick. Okay, so I would say, we're At this point, it's not like that big of a deal, but I would say that I would leave it like that. This plays Towers of Hanoi with 3 discs, 3 towers. We can certainly expand it to handle all the international professional rules if we wanted to, but I think this gets our point across of working with stacks and having a somewhat realistic use of stacks. Make some sense? All right, so now what we're going to look at next here, and we're out at 55, right? Not 50, we're at 55, okay. So we'll look at this for 4 minutes. Is if you remember back, I think I usually do this in the 200 class because I usually try to throw some assignment in 200 and then another one in 250 that kind of scares you so that in the future you realize how much better you've gotten. So when you guys had 200, did you do the process expression assignment where I had like, you had to solve for like 123 plus 17 minus 28 or something like that and give me like what the final answer? Do you remember that at all? Okay, so the issue is this. So I usually give some assignment like this that starts off with, I might say you take in a string. It's kind of along the lines of string manipulation. Is that you take in a string that's 123 plus 14 minus 28 times 2, like that. And you need to somehow process that expression and do all the math, right? The challenge becomes this. We know as, pseudo mathematicians that orders of operation is important when doing math. We know that this guy right here is actually what happens first because multiplication comes before addition and subtraction. Does that make sense? Which means, and then within addition and subtraction, it just happens left to right. Those are the orders of operation. But based on what we would have known in 200 or 250, if I said do this with orders of operation in mind, it becomes a very difficult problem. Very, very difficult problem. So usually in that first assignment, I say something like, don't worry about orders of operation, just go left to right. So then it was more of an activity of, okay, I need to piece out these individual little nuggets, right? Piece out these individual little nuggets and build. So I'll have maybe a collection of 123 linked to the 14, linked to the 28, linked to the 2, something like that. And maybe we actually exploded even more just for this example. And also for time. 14. Minus 28 times 2. Okay, so we have something that looks like this. So what we want to do is we want to take a string that looks like this and turn it into a linked list that looks like this initially. That's our first step given time. So for our homework, and we can use C++ style strings, which we looked at, which work like Java strings, right? So homework, given a string like this, and it can be any string, but here's an example string. Produce a linked list like this. And I would say each of these, you could have each of these be strings. So you're really making a linked list of strings instead of a linked list of ints like we currently have. Right. And really, it's a simplified linked list because we're always just adding to the end, right? We add the 23, then we add the plus, then we add the 14, then we add the minus. You don't have to make an all encompassing linked list. Just produce this dude from this dude. That's your homework for Wednesday. And then we'll look at how do we do that with shunting yard. How do we take advantage of that format and apply shunting yard to do the math and orders of operation? Questions, comments, concerns, bribes? All right, I'll see everybody on Wednesday.